Hi and welcome to the third SPSS tutorial video for PSY 520. In this video we are going to talk about repeated measures analyses, specifically dependent samples t-test and repeated measures ANOVA. So just as a bit of review, repeated measures designs are research designs in which the same participant or the same group of participants are measured more than once. And they are in contrast to between subjects designs where groups of participants are measured only once and the comparisons are happening between the groups. So in this example here, let's take a look at our data set. We have scores from 15 participants on 3 variables: rest, read, and walk. Now what these are heart rates. So heart rate for 1 minute during these 3 activities. So the same group of participants, the same 15 participants, were measured, had their heart rate measured when they were at rest, when they were reading, and when they were walking. So again, the key there is that each participant was measured 3 times. Once at rest, once when they were reading, once when they were walking. Now, somebody interested in this, in comparing the heart rates from people at rest to when they're reading to when they're walking, could do this in a different way. Rather than have the same exact participants and measure them 3 times, you could of course have 3 totally different groups of participants, measure them each once, and compare your group means. So you could have a rest group, a read group, and a walk group. Calculate the mean of each group, compare them using, in this case, a one-way ANOVA, and you would have a between subjects way of looking at that. And that would be fine to do. But there is a benefit to the repeated measures analysis, and that is that each participant basically serves as its own control group. So when you measure the same group of participants multiple times, like we have here, you are able to run statistical tests with fewer people. In statistical terms, these tests have more power, which basically means they're more sensitive and better able to detect significant effects. So there is certainly a benefit to running a repeated measures analysis. With that said, let's go ahead and kind of dive in here. So just a quick recap. I already kind of explained these variables, but again, we're looking at heart rates for 1 minute during each of these 3 activities: resting, reading, and walking, and they were all measured from the same group of 15 participants. Now, before we start comparing means, one thing that we like to do is take a look at the means just descriptively before we run any significance tests. So if we go to Analyze and we go to Compare Means and we go to Means, now we've done this before, and actually I started to go down the wrong path there. That's not what we're going to do. We have gone to Compare Means and clicked on Means before. We've done that. That works when you're comparing the means of 3 separate groups, but I kind of caught myself there because now we don't have 3 separate groups. We have really 1 group but 3 separate variables. So in that case, we want to go to Analyze, Descriptive Statistics, and then Descriptives. So we will go there. We can put our 3 variables over into the Variables box. We can click OK. And we're going to get this very simple table that tells us each of our 3 variables, the minimum, the maximum, the mean, and the standard deviation. So we can see right here that we have 15 people in each group. Not surprising because there's only 1 group, so it's really not even 3 groups. It's 1 group that measures on the 3 variables. We have the minimum and maximum for each. We have the mean for each, and we have the standard deviation. So just looking at the means, we can see that the heart rates are pretty similar when people are at rest and when they're reading, and they seem quite a bit higher when they're walking. So again, we do this, looking at these means like this, to get a sense of the differences, so we have a sense of what to expect when we run our inferential statistics. So if we go back to our data set and run a dependent samples t-test, we can compare the means for 2 of our variables here, because again, a t-test only works for 2 variables. Now we actually already covered dependent samples t-tests back in PSY 510, But just quickly as a matter of review, we can go to Analyze, Compare Means, and SPSS calls these tests paired samples t-tests. So if we click on paired samples t-test, it's simply asking you for the pair of variables. We can put rest, we can put read, and now it's going to compare the pair there, rest and read. We click OK. We have several boxes that come up for our t-test. The first two are really just descriptive information. It's that third one that shows us the test of the difference between resting and reading heart rates. What we can see, if we go look at the p-value, is that it is not significant. That is certainly not less than 0.05, so that is telling us that we do not have a significant test here. Now, they also show us the means again of the resting and reading variables. We had already seen them. We had already seen that they were very close, so we're really not surprised here that we do not have a significant test. But that is how you run a dependent samples t-test, also known as a paired samples t-test in SPSS. And again, the critical thing here is that the same group of participants were measured at rest and reading. They were not two separate groups. If they were two separate groups, we'd be looking at a independent samples t-test, but because these are two measurements taken from the same group, we are using a dependent samples t-test. And that fact that it's participants measured in the same group twice is what implies a repeated measures design. So now we can go ahead and look at a ANOVA analysis on these variables, and that would be a repeated measures ANOVA because we have three different variables here, all measured from the same people. So again, just like with the between subjects ANOVA that we've talked about in the past, we're using an ANOVA because we're comparing the means on more than three variables. What makes it repeated measures is that these same participants were measured 3 times. So if we head up to Analyze and we go to the general linear model, that is where we found the factorial ANOVA before. Now we're going to go down to repeated measures. And that brings us to this box here, and it asks us for our within subject factor. So it's asking us basically what is kind of an overall variable name for your repeated measures variables. Now in this case we could say something like heart rate. And we can say that there are 3 levels because we have the resting level, the reading level, and the walking level. So if we click Add, it's been created, and we can then go to Define. So what we've basically done is create this heart rate variable, and now we're telling SPSS which of our columns belong to it. And in this case it's pretty simple because we've only got 3 columns. All of them are heart rate measures. So it's asking here for the within subjects variables, heart rate, and then it's asking for the 3 pieces there. So we can go ahead and just enter them in one right after the other. And then if we go ahead and click OK, we are going to get down here our F-test. Test of within subjects effects. That is our F-test. That is what tells us whether or not we have a significant test. Now this gets a little bit confusing because there was something known as sphericity that is important. Let me jump back here. When we look at our output for the repeated measures design, we have as our second box this test of sphericity. You can read about this in your textbook, but essentially it's one of the assumptions of the repeated measures ANOVA. In a sense, you do not want this to be significant, because if this is not significant, it tells you that you have proportional variances in your conditions. In any event, this is not significant, so we can go ahead and just use this first line that says sphericity assumed. If this was significant, technically you would want to use one of these other values. Greenhouse geyser is a kind of corrected value that accounts for this sphericity. Now we're kind of getting pretty technical here, and to some extent this is beyond the scope of the class, but this is the way SPSS depicts everything, so you kind of have to confront it. But again, as review, there's an assumption called sphericity. You can read about it in your textbook, If this sphericity test is not significant, then you should be using this line that says sphericity assumed. If it is significant, technically you should be using the greenhouse geyser. Now you're going to get very similar results in most cases. And in this case, clearly we have very similar results. We can see that the p-values are significant in both cases. We can see that the f-values are in fact identical. But in any event, we're going to interpret the first row, sphericity assumed. We have a significant test. Our p-value is less than 0.05, certainly. Again, that f is very large, suggesting that we have a significant test. So what this is telling us is that indeed there are significant differences amongst the three variables. And again, we had an idea of that because we could see from the beginning that the heart rates when people were walking were much higher than the other conditions. So because this is an ANOVA, we could do some contrast tests, which we talked about in the context of the one-way ANOVA. You can still do those with a repeated measures test. What you can also do is look at what's known as a mixed ANOVA, where you have both a within subjects variable and a between subjects. So actually, if we go back to our data set, I'm going to actually create another variable. And because I'm not very creative right now, I'm just going to call it sex. And I'm going to have values of 1 for male and 2 for female. So what I've done is add a between subjects variables, because obviously males and females are two different groups of participants. As you can see, my power is running low, so hopefully I get this done before it dies on me. But I'm going to go back to the data, and I'm just going to make up right here some data, a bunch of 1s and a bunch of 2s. So now we have not only our repeated measures variable, but we also have a between measures. So if we go to Analyze, General Linear Model, and then to Repeated Measures, we have our within subjects variable already created. It's there. We now have sex. We can put that as a between subjects variable and click OK. And now what we've done is conduct a ANOVA where we have a repeated measures variable and a within subjects, or excuse me, a between subjects variable. So that allows us to test, just like before with the factorial ANOVA, not only the main effect of heart rate and the main effect of sex, but also the interaction between the heart rate variable and sex. And here we can see that it's not significant, so there is no difference there between males and females when it comes to their heart rates on those variables. So again, just to recap, we have looked at repeated measures analyses here, the dependent samples t-test when you're comparing two group means, the repeated measures ANOVA when you're comparing at least 3 means, and then at the end we even added in kind of the mixed measures ANOVA where we had one variable that was repeated measures and one that was a between subjects variable. So that is how you run those types of repeated measures analyses in SPSS.